All right, so this is Pre-Calculus A, Unit 6, Conic Sections, Lesson 1, Analytic Geometry. Analytic geometry basically is the geometry in which we place geometric shapes on a coordinate system, and we'll call it the Cartesian coordinate system, an XY graph, so to speak. Right? And there are two basic formulas that you need to know in order to do analytic geometry. One is distance. Let's say we've got 2 points. We'll call this x1 and y1. And we'll call this x2 and y2. And we're looking for the distance between them, the linear distance between them. I'm going to go through a little bit of a process to derive the formula, but really it's just a matter of using the formula. However, understanding where the formula comes from goes a long way towards helping you use the formula more efficiently. So, in this case, we draw a right triangle, height and length, and you will recall that if I want to know how far along we went to the right or the left, we're looking for the change in x, which is the absolute value of the difference in the x's, x2 minus x1. Subtract the x's, you know how far you traveled either left or right. Over here, the change in y, the height of the triangle, is y2 minus y1. Absolute value because we don't care about direction, we're just talking about length. Okay? And you may recall also from the Pythagorean theorem that the length here, we'll call this d squared equals change in x squared plus change in y squared. So if I take the square root of both sides, we end up with d is the square root of delta x squared plus delta y squared. Okay? That gives us the formula here for distance. Distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Square root. Okay. And you may have a little bit of a question, well, what happened to the absolute value? Well, when you square a negative, you get a positive anyway. So squaring takes care of the absolute value. The result of squaring is always positive. Okay, let me apply this to a particular set of coordinates and show you how I think it through. And you can use my way of thinking, or you can come up with your own. Let's say I've got the point 3, 8, and 6, negative 4. I consider the change in x. How far is it between 3 and 6? My conclusion is it's 3 spaces. How far is it, the change in y, how far is it between 8 and negative 4? Well, my conclusion is it is 12. I don't care if it's 12 up or 12 down, because when I square the negatives, they're going to be positive anyway. So my distance becomes the square root of 3 squared plus 12 squared. Okay? And so 3 squared is 9, 12 squared is 144, 9 and 144 is 153, and we can use a calculator to come up with the approximation for that. All right? So that's distance. And then the other formula you need to use is midpoint. Okay? And I'm going to go ahead and put this on the same page here. Midpoint stands for middle point. Midpoint. Okay? If I have two numbers on a number line, like negative 5, 1, 2, 3, 4, 5, 0, 1, 2, 3, negative 5, 3, and I want to find the midpoint between those two on a number line, I might be tempted to count the spaces between them. And that's a good temptation because it's logical to do so. And I conclude that there are 5 to get to 0 and 3 to get to from 0 to 3, so there's a total distance of 8. And then I would be tempted to say, well, it's logical to take 8 and divide by 2, and we get 4, right? And so I'm going to count off 4 from negative 5. 1, 2, 3, 4. And I conclude that negative 4 1, 2, 3, 4 from 3 as well, is the midpoint, and I would be correct. Okay, but let's put that into a formula. Okay, let's put that into a formula. It's actually a little easier to do this problem this way. Take 5, negative 5, add 3, and divide by 2. That is the arithmetic average of the two. Negative 5 plus 3 is negative 2. Negative 2 plus 2, whoops, and I put negative 4. My mistake. You were probably screaming at the camera, "What are you doing?" That's not negative 4. That's negative 1. All right. So, negative 1, right? We counted off 4 from negative 5, and we counted off 4 from 3, and ended up at negative 1. My apologies. Negative 2 divided by 2 is negative 1, right? And so it turns out that the average of the two coordinates works. And all the midpoint formula is an average of two coordinates, right? x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And let me do it in the case of 3, 8, and 6, negative 4. So the midpoint in this case is 3 plus 6 divided by 2, comma, 8 plus negative 4, or 8 minus 4, divided by 2. That gives us the midpoint is 3 plus 6 is 9. 9 divided by 2 is 4.5, or 4.5. 8 minus 4 is 4. 4 divided by 2 is 2. And there's the midpoint. Okay? So hopefully that makes sense, aside from my whoops. You have a wonderful day.